In VR applications, there are many moving dynamic objects, such as other user characters, non-player characters, and vehicles. These dynamic objects can interfere with the user's path or interact with the user as obstacles, and users have typically tried to navigate while avoiding collisions with them. Different locomotion techniques can lead to variations in how users control their movements in response to dynamic obstacles, potentially affecting users' spatial knowledge and experiences. Therefore, it is meaningful to investigate how different locomotion techniques affect user performance and preferences depending on the degree of dynamism of the VE. We selected 3 locomotion techniques: joystick, teleportation, and redirected walking, all commonly used for VR navigation. When using a joystick, the user presses a stick, directional button, or pad in place to continuously move the viewpoint in a selected direction. Teleportation allows users to instantaneously travel long-range distances by jumping to a desired destination using controller. RDW is most similar to actual walking, and it allows users to navigate in virtual environment that is considerably larger than the limited physical space. The experimental design consists of 6 different conditions, depending on the environment and locomotion techniques. In the JS condition, participants use a joystick in a static environment. TS condition means that users teleport in static environment. In the RS condition, participants use a redirected walking to move the static environment. In the JD condition, participants move in a dynamic environment using a joystick. TD condition means that users teleport in a dynamic environment. In the RD condition, participants use a redirected walking to move a dynamic environment. Participants had to move around the virtual space and memorize the 7 words. After each condition, participants completed questionnaires asking about their spatial knowledge and user experience. We found interesting results for each condition and each type of spatial knowledge. Joystick was the most effective technique for spatial knowledge acquisition in a static environment, while RDW was the most effective in a dynamic environment. Travel time and distance were lowest for joystick condition, while the collision frequency was highest when using teleportation. In the RDW condition, participants had the highest values for immersion and usability. In addition, we observed some interesting findings. We investigated the effects of different locomotion techniques on spatial knowledge acquisition, task performances, and user experiences when navigating 2 types of environments. The main findings presented can provide guidelines for locomotion interface design for practitioners who need to design VR applications.